Good morning again, grade 9. Welcome to our next online lesson where we are still multiplying and dividing polynomials, but now it's part 2. And part 2 has to do with multiplying and dividing by a monomial. Now, a monomial, as we'll remember, just has one term. And the key aspect of what we're kind of doing here is that whatever that one term is, it's going to have a variable. And that's really what makes part 2 part 2. And so we're gonna begin today with a very simple kind of expression. We're going to do 2x, and that's going to be our monomial. We're going to multiply 2x and 5x plus 3. And what we can kind of think of this as is the 2x monomial is being multiplied by both 5x and by 3. Both the 5x and the 3 of our polynomial. So we have a polynomial multiplied by a monomial, and we kind of want to go through how this is going to turn out. And for the most part, our concept explanation today is for 2x multiplied by 5x. And that's because we kind of already know how to multiply 2x by 3 because we just did that, except it looked backwards almost. It was 3 multiplied by 2x. And if we'll recall, 2x, if I have 3 groups of 2x, well, here's 3 groups of 2x. And that would be 6x. So the 2x multiplied by 3 is going to give me 6x. So let's just kind of write that down. So this is going to simplify to be 6x. It's going to be positive. And then there's going to be another term here, which is going to represent 2x multiplied by 5x. And the way I would like to explain this today is a couple of different ways. And our first explanation is going to be, well, let's do 2x multiplied by 5x, and let's choose some values for x. So we're going to choose some values for x. We're going to plug in. We're going to have a lot of data here. We're going to kind of rework it back to one simple expression which applies to everything we do. So the first x value I'd like to choose is x is equal to 2. And so if x is equal to 2, well, 2x means 2 multiplied by x. After I do that, I'm going to multiply this by 5 multiplied by x, where here x is 2. So this will then look like 2 multiplied by 2. And that whole thing is multiplied by 5 multiplied by 2. And so therefore, I have 4 multiplied by 10. And that equals 40. Okay, so that's the first one we want to do. Next up, we're going to do x is equal to 3. Well, we still have 2x times 5x. So we have 2 times 3, because that's what x is, 2 times x, multiplied by 5 times 3. And that comes out to be 6 multiplied by 15, and that is equal to 90. Next, we'll do x is equal to 4. So we have 2 times 4 multiplied by 5 times 4. This is 8 multiplied by 20. So this is 160. Okay, we're going to keep going for a little, few more kind of data points here. We're going to do x is equal to 5 next. So we have 2 times 5 multiplied by 5 times 5. So that is 10 times 25, and that is equal to 250. We'll next do x is equal to 6. So we have 2 multiplied by 6 multiplied by 5 times 6. So we have 12 multiplied by 30. Well, 10 times 30 is 300, and 2 times 30 is 60, so we have 360. And we'll do one more. We'll do just down here, x is equal to 7. So now we have 2 times 7 multiplied by 5 times 7. So now we have 14 multiplied by 35. 10 times 35, that is 350. 4 times 35 is the same as 70 times 2, which is 140. So I have 350 plus 140, and that is 490. And so I'd like to examine these numbers that we got, and I'm kind of gonna do this down here. So when x was equal to 2, the answer we got was 40. And when x was equal to 3, the answer we got was 90. And when x was equal to 4, the answer we got was 160. And let's just examine those two up here. The 4 really says it quite nicely. No, the 40, I mean. That's 4 multiplied by 10. Or actually, let's do 10 multiplied by 4. 90 wasn't kind of that same pattern, but 6 by 15 is equal to 90, but I can rewrite that like 10 times 9. And 160 I can rewrite like 10 times 16. So let's kind of do that here. 10 times 9, 10 times 16. Okay, 250 was the next one. X was equal to 5 in that case, and that's 10 multiplied by 25. Next should be 10 multiplied by 36, which I can rewrite 360 to be 10 multiplied by 36. And last being 490 can be rewritten as 10 multiplied by 49. That's x is equal to 7. And so hopefully we're beginning to see a bit of a pattern here that, okay, 10 seems to be pretty consistent here. It seems to always be the case that I can rewrite my answer as 10 multiplied by something. In fact, the next thing should be 10 multiplied by 64. And the 10 seems to be consistent. Where did I pull 64 from? Well, that would be when x is equal to 8. Okay, perhaps you don't see it. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And 8 squared should be 64. So that's our pattern here. It seems that we have altogether, no matter what x is, we get 10 multiplied by the square of x. 4 is the square of 2, and 25 is the square of 5. So we get 10x squared, which, remember where this all came from. 2x multiplied by 5x. So it would seem that when I have 2x multiplied by 5x, I get 10x squared. And so, well, let's examine where each thing comes from. 2 times 5 is 10. That's where my 10 kept popping up from. And then we have x multiplied by x. And it'd be a little more evident if I had the algebra tiles in front of me. But if I have an x tile, and I make another group, if I group it with another x tile, it almost looks like I can fit an x squared in here. And it turns out that that's exactly, it would perfectly fit right underneath. And so that's kind of how that works, is that x multiplied by x gives me x squared. Okay, and then we just take our coefficients in front and multiply those together. So altogether, 2x multiplied by 5x turns out to be 2 times 5 is 10, and x times x is x squared. And we didn't just kind of do very little to show this. We kind of plugged in a lot of different x values, found ourselves a bit of a pattern, which isn't always necessary to do, but it kind of is nice when these things happen in math. And it's kind of what we're exploring in a lot of what we do in math. So remember, this all stemmed from, well, what's 2x multiplied by 5x? Turns out that it's 10x squared. And so that's kind of our concept building here. Let's do a couple of multiplication examples. So our first example, kind of keep it simple. What do we do if we have 3x multiplied by x plus 4? Okay, so this is, we've kind of already seen something like this before. It's not all that dissimilar to our last example. It's kind of same structure. We have, instead of 2x, we have 3x. Instead of 5x, we have x. And then we have a constant term here, 4 instead of 3. So the way we can kind of do this is 3x multiplied by x. Well, there's kind of a 1 in front of here. So 3 times 1 is 3. So I got to do this multiplication first. 3 times 1 is 3. And x times x, we just found out was x to the power of 2. And then we have plus, well, what's 3 times 4? 12. And this will include an x, which comes into play here. Okay, so this kind of multiplication here, 3x multiplied by x plus 4, that is the same as 3x squared plus 12x. Let's try one more. Let's try 3x squared multiplied by 2x minus 3. So now this is our polynomial and this is our monomial. So how do we kind of reconcile this? Well, let's just start with 3 times 2, that is 6. And now, what about x squared multiplied by x? Let's do a similar practice. We won't do it as in-depth as we did before, but let's just say that x is equal to 4. And so now we have x squared multiplied by x. So now we have 4 squared multiplied by 4. If we kind of break this and expand it all out, we have 4 squared is 4 times 4, and then we have another multiplication of 4. Well, that's 4 cubed. So, do we play it back? X squared times x, that's going to be equal to x cubed. And so, we can say, hopefully now we can say 6x cubed is what I get from 3x squared multiplied by 2x. And then what's 3x squared multiplied by negative 3? Well, 3 times 3 is 9, so we get negative 9x squared. And let's do one more example, and I'll walk you through how I usually tackle these. Because I'm not really ever drawing algebra tiles. I'm not really ever doing this. Because now, since I hope we have a little bit of understanding, we can walk you through how I would envision you interpreting these problems. So let's say I have 5x to the power 4 multiplied by 2x to the power of 3 minus 2x squared minus 3. Okay, so 5x to the power of 4 is going to get multiplied by each of these terms here. And it may not be quite so obvious. However, if I just take a look at this particular problem here, what is the power of x? Well, x has a power of 1 in both. And 1 plus 1 is 2. We'll do it here. X has a power of 2 and x has a power of 1, and 2 plus 1 is 3. So that's the other way we can kind of look at this, is let's just do all the accounting for these terms here. 5x to the power 4 multiplied by 2x cubed. 5 times 2 is 10, and then 4 plus 3 is 7. That's going to be what the first term multiplied by 5x to the power of 4 equals out to be. So now 5x to the power of 4 multiplied by negative 2x squared. 5 times negative 2 is negative 10x to the power of 6. And then negative 3 times 5x to the power of 4 is minus 15x to the power of 4. Okay, time for us to tackle division. And this one works oppositely to multiplication. These are division and multiplication are opposite to each other. So let's actually say for a second that we start out to be 10x to the power 7 minus 10x to the power 6 minus 15x to the power 4. And let's say I divide that by 5x to the power 4. Well, you may think, well, that's very scary, but I mean, I'm pulling these numbers from what we just did. And so let's play the analogy here. Let's say I have 7 multiplied by 3. Well, it gives me 21. Okay, so imagine that for as simple as it gets, we have something multiplied by something else, and I get an answer. 7 multiplied by 3 is 21. And then I go ahead and I say, okay, what's 21 divided by 7? Well, I think a lot of us would be able to say 3. So the same can be said here. Our answer divided by what we had before should come out to be this. And so let's systematically go through kind of how I would do this. And I would say each one of these terms is divided by 5x to the power 4. So 10 divided by 5, that's 2. And x to the power 7 divided by x to the power 4 would be x to the power of 3. And so even if I didn't have this in front of me to know that I should be getting to x to the power of 3, I can always go through each of those divisions. So 10 divided by 5 is 2, and then x to the power 7 divided by x to the power 4, I'm doing 7 subtract 4 to get 3. In fact, we did this a few months ago at the beginning of the year with our exponent laws. If I have x to the power of 7 divided by x to the power 4, the division said that I should subtract the exponents to give me x to the power of 7 subtract 4 is 3. Let's try the next example, the next term here. Negative 10 divided by 5, that's negative 2. And 6 subtract 4 is 2, so I have x to the power of 2. And then 15x to the power of 4 divided by 5x to the power of 4. Well, 4 subtract 4 is 0, so we could say minus 3x to the power of 0. The 3 comes from 15 divided by 5, so that's 3, it's a negative. Hope you follow me on that. So now I have x to the power of 0. Well, I didn't have that before, I just had negative 3. But if we recall, anything to the power of 0 is quite simply just 1. So what's 3 multiplied by 1? It's just 3. So I'm hoping that we're seeing some of the patterns here. Let's try another example for division. This being example 1. And then, so let's try 3x to the power of 3 minus 12x to the power of 4 plus 24x. And let's divide all of this by 3x, and that's it. Remember, I'm only ever going to be dividing by one thing. not that I can't divide by more, but if I suddenly said let's divide by 3x plus 3x squared, that's a totally different thing. We truly don't learn how to do that until our last year of high school. Now, let's go with this to begin with. Okay, sometimes it's nice to write the power here of x as being x to the power of 1 and say, okay, 3 divided by 3, that's just 1. So that kind of cancels out. And what's x cubed divided by x? Well, 3 subtract 1 is 2, so I just have 1x squared here. So 3 divided by 3 is the 1 that we don't have to write because it's implied. And then x cubed divided by x is just x squared. Next up we have 12 divided by 3, or negative 12 divided by 3. We have negative 4x to the power of 3. And then the power of 3 comes from 4, subtract 1. And then finally we have 24 divided by 3, that's 8. And then x divided by x, that actually just cancels that out completely. And I just have 8. It would be, if I did the exponents, I'd have 1 subtract 1 would be 0. And I'd have the same kind of thing I did up here with x to the power of 0, and it would go away. Sometimes what I've seen students do is just to kind of account for what they need to do, they'll go, they know they got to divide everything, so they'll do 3x cubed divided by 3x, and then they'll say, okay, that's equal to x squared. And then they'll do negative 12x to the power of 4 divided by 3x, and they'll say, okay, negative 4, and then x to the power of 4 divided by x would be x cubed. Just getting the same thing here. It's just another way that I've seen people account for what they need to do. And then finally, 24x divided by 3x, and so the x's cancel out, and you're left with 8. So if that works for you, I certainly encourage it. Sometimes I'll even do it on scrap paper and then put my answer in that kind of form of x squared minus 4x plus 8. Whatever works. Hoping that we're understanding a little better how that multiplication and division by a monomial would work, and good luck with your practice. Let me know if you have any questions.